So hey guys, in this video we are going to learn about partial differential equation, how to form the partial differential equation by eliminating the arbitrary constants. So arbitrary constants here it will be A as well as what B. Okay, so A and B will be what the partial differential equations. Okay. A and B will be what arbitrary constants. So we have to eliminate that arbitrary constant. So let us see. Before that, you need to understand few things. So now here P is represented for the partial differentiation del z by del x, or it is represented as z subscript x. Okay, so that is the first thing. Next, Q is represented for the partial differentiation, that means del z by del y, and it is represented that z subscript y. Okay, next PQ over R is also there. R is basically the double differentiation. Okay, so it is partial differentiation again for the P term. So P term again we are partial differentiating, so it becomes del square z by del x square, and it is said as z x x. Now T is basically the partial again differentiating Q value, that is del square Z by del Y square, it is given by ZYY. Now one more term is there, which is S term, that is del square Z divided by del X into del Y. Okay, that is given by ZXY. We will be dealing all the things. First we'll understand how to eliminate basic problems. We are saying how to eliminate the arbitrary constants. The first problem we are taking here, so this basically has what A term is there, B term is there, we have to eliminate. So first we are going with the P, which is the partial differentiation with respect to X. So P is given by del Z by del X, and it is equal to, always remember partial differentiation, if X is sitting below, that particular term is treated as the variable, other term becomes the constant. So here X is treated as variable, Y is a constant. Okay, so Y term is a constant, here B is also a constant, so that particular entire term becomes constant. I hope you understood. So this meaning I'll write over here. For the P term, X is treated as the variable and Y is treated as the constant. For your understanding purpose I am writing. So this entire term is constant, so I can write constant term first because it is in multiplication. Okay, next X plus A differentiation we have to do. X differentiation is what? 1. A differentiation is what? 0. So 1 in 1 plus 0 is 1. 1 into anything is 1 itself. So if you want, you can multiply with 1. Next, coming to the Q term. So Q term again the same thing. Del x z by del y. Now with respect to y. So here remember y term becomes the variable and x term becomes the constant. This you have to understand here. Now here z, the b term, we'll see the x plus a term first. Now x is a constant. Okay, a is also a constant. So we can directly write over here x plus a. Right, x plus a I can write. This is a constant. See, multiplication, there is a difference between multiplication and addition. Okay, here it is multiplication of two factors, two linear factors. That's why I'm writing x plus a as a constant term. For example, if we are writing 2x square differentiating, you will write 2 as a constant, then a differentiation of x square as 2x, right? So 2 is sitting as a constant. Here it is multiplication, that's why you wrote. If you are writing 2 plus x square differentiation, 2 is a constant. So directly this constant term becomes 0. You will write 0 plus 2x. You won't write 2 plus 2x, right? There is a difference between addition and multiplication, that the differentiation part. Okay, so here also same thing, x plus a is a constant which is getting multiplied with y plus b. That's why I have written here x plus a as a constant term, keeping outside. Don't write 0 and okay. Y plus b, here b is a constant, fine. Y differentiation is 1. 1 plus constant differentiation 0, so it will be 1. Okay, if you want, you can write 1 plus 0, the same thing only. What values you have got? We have got p value as y plus b and q value as x plus a. Now can I eliminate these two values, the a and b values, can I eliminate by using p and q, or otherwise do I have to go for r and p also? Not required, because in the function z you can see Z is having x plus a and y plus b. So directly I can substitute there, right? So Z becomes, instead of x plus a, I'll substitute q. So it will become q into, instead of y plus b, I can substitute p. This you can write it as Z is equal to what? Pq. So where is the arbitrary constant? See, the a and b was the arbitrary constant. So this arbitrary constant is basically a and b. So a and b has been eliminated. So here there is no a and b. So this is the required partial differential equation. Okay, this is the required. This was the basic problem. Just we substituted. So the thing is that it is not necessary after p and q you will be getting some values here you can substitute. It is not necessary. Complicated problems you have to find r, t, s, whatever is there. We'll see in the upcoming videos.